Okay, number 12. I don't know what the directions are. I apologize, but I'm going to make some directions up here. What can we say about the derivative f prime of x and the second derivative? So the first derivative is positive everywhere because the slopes are always positive. And the second derivative is negative everywhere because those slopes are decreasing. The rate of change is getting less. I'm saying the same thing over and over again. So just differently, it's concave down. All of those are things that things that happen when the second derivative is negative. All right, 16. An accelerating sports car goes from 0 to 60 in 5 seconds. Its velocity is given in the following table, converted from miles per hour to feet per second, so that all measurements are in seconds. Find the average acceleration over the first 2 seconds. So average acceleration is equal to the average rate of change of velocity. Okay, so that's going to be over each of the first 2 seconds. So that's going to be v of 1 minus v of 0, change of velocity from 1 to 0 over the time. So that'd be 30 minus 0 over 1, which is 30. Ooh, what are my units here? Well, velocity units are feet per second over time per second. So sometimes we say 30 feet per second squared. That means for every second, your velocity is increasing 30 feet per second. Okay, and then acceleration over the first 2 seconds would be over here, v of 2 minus v of 0, or 2 minus 0. So that would be 52 minus 0 over 2 minus 0, which is 26 feet per second. That's the numerator, over 1 second, which is 26 feet per second per second. Or like I said before, we write that feet per second squared. Okay, let's look at 28 and 29. 28, at which of the marked x values can the following statements be true? Okay, f of x is negative. That's my y values. So where are the y values negative? At x4 and x5, right? Negative y values. Where's the derivative negative? Well, that's when the slope is negative, so that'd be at x3. Right there, x4. Where is f of x decreasing? Okay, where the function is going down from left to right. That'd be at x3 and x4. And notice those are the same because f decreasing and the derivative negative, these two mean the same thing. What about f prime decreasing? F prime of x decreasing means f double prime of x is negative. All right, does that make sense? And this is another way to look at it visually, is it's concave down. Okay, so where is this concave down? x1, x2, x3. Okay. Where is the slope of f positive? x1, right, x2, and x5. And where is the slope increasing? So I get f prime of x increasing because that's the slope. Means f double prime of x is positive. So it's going to be at x4 and x5. Okay, a lot of stuff there. Does that make sense though? Okay. And 29. 253 gives the position of a particle at time t. Which of the marked values of t can the following statements be true? And, oh good, I have the picture. I don't know if I have the picture. Okay, so which values of t, this is, okay, and this is the position. So call that S. So we need to remember this. We got position, and then the derivative of position, so that's equal to S. S prime is the velocity, and S double prime is the acceleration. All right, rate of change of velocity, or rate of change of position is velocity, rate of change of velocity is acceleration, like we talked in class. So A, position is positive, T3, T4, T5. B, velocity is positive, velocity is S prime, which is the slope, T2, T3, right? Slope's positive. C, acceleration is positive. That means the second derivative is curving up because that's when the slope is increasing. So it's going to be at T1, T2. And T5, it looks like it's kind of curving up there too, right? D, position is decreasing. So S is going down from left to right. So that'd be T1, T4, and T5. E, velocity is decreasing. Velocity is the slope. So the velocity is decreasing. So when is the slope getting smaller and smaller? Well, S prime decreasing means S double prime is positive. Okay, get comfortable with this, working around this. This is um, a good understanding if you can see this like this. So remember, oh, I see it. I messed it up. Here, you gotta have a good understanding. I do it wrong. Sorry, I'm getting tired here. So decreasing means the second derivative is negative. So that means it's something like this or something like this, right? Where the derivative is getting smaller and smaller, right, as we go from left to right. So S double prime is negative, means it's concave down is the easiest way to look at it on a graph. So that'd be at T3 and T4. All right, does that make sense, guys? And yeah, I apologize for not talking earlier about concavity. We described it and drew pictures, but I just didn't say it. So, or those words. So there you go, and we will talk about it more on Wednesday as much as we need.